Automating file manipulation with Python is a valuable skill, whether you're a data scientist or just trying to optimize your workload. In this lesson, you'll discover how to use automation with VS Code to open, read, and close files with Python, and how you can iterate through a file and process the data within. Go ahead and get inputfile.txt from the exercise files folder. This file contains some data about people who've recently taken their behind-the-wheel drive test. Each row has the first name of the person, their age, and whether they passed or failed their test. Now let's say the goal is to read inputfile.txt and print out its contents. Start with a new Python file. Now call the open function and pass in the file name including the file type as a string. And you want to pass in the string r for read as a second argument. Next, print out the contents of the file. To do this, call the print function and then inputfile.read. Lastly, call the close function of the file. This is to make sure the file is closed properly after it's been read. This is a best practice to prevent unintended file changes. Now save this program. You can give it the name read_files.py. To run the program and test it out with VS Code, go to Terminal, New Terminal, and then run the following command. python3 space read_files.py. There you go. Here you can see the contents of the text file that you just read in. What if I don't want to print the entire file? Instead, I want to print just the data that represents people who passed the behind-the-wheel drive test. For this, you need to iteratively check each line in the file, determine whether the person passed the drive test, and only if that's true, print out that line. Write a for loop that iterates through each line of the file. Inside the loop, split the line using the .split function, which defaults to splitting on white space. When reviewing the structure of the inputfile.txt, you'll notice that each line consists of a name, a white space, a number that represents age, a white space, and a letter that represents whether the person passed the test or not. The letter is P if they passed and F if they failed. Once you split on white space, you're left with a list of 3 elements. Given that indexing starts from 0 in Python, the P or F letter is located at index 2. So I'll write an if statement that checks whether the element at index 2 is equal to the string P. If that condition is true, I'll print out that line. Now save your changes and run the program. There you go. These are the lines of the text file that contain P. Now that you've learned how to read and iterate through files with Python, go ahead and try it out for yourself with another text file. File manipulation automation can really be a game changer. With this, your scripts are unchained and can access external files anywhere, and your datasets now persist even after the program is finished running. In this lesson, you'll explore how to use automation to write files in Python based on specific conditions and verify that the files were created properly. Open write-file startercode.py from the exercise files folder. This contains some starter code with comments that guide you through the parts you'll fill in yourself as you follow along. The first line of code opens inputfile.txt with the intention of reading it. This input file contains some data about people who've recently taken their behind-the-wheel drive test. Each row has the first name of the person, their age, and whether they passed or failed their test. The letter P indicates passing the test, and the letter F indicates failing the test. Your goal is to write all of the lines that pertain to people who passed the test into a new file called passfile.txt, and all of the lines that pertain to people who failed the test into a new file called failfile.txt. So call the open function to create a file called passfile.txt that the program will write to. Pass in the string W as a second argument to indicate that you want to write into the file. Next, call the open function to create another file called failfile.txt that the program will write to. Then comes the for loop. The for loop should iterate through the lines in input file and check if each line has P at the end. If so, you write that line into pass file. Otherwise, you write that line into fail file. After the for loop, the input file gets closed. Now add a line to close pass file and another line to close fail file. Now save your changes. To run the program and test it out, run the following command: python3 space write underscore files underscore starter underscore code.py. Confirm that the new files were created successfully. First, locate passfile.txt. Open it up and check that it only contains lines with p at the end. Then locate failfile.txt. Open it up and check that it only contains lines with f at the end. And there you go. The program worked. Now that you've learned how to write files with Python, you can practice creating and writing to new text files using Python automation on your own. Python is magic, and the command-line interface, or CLI, is your magic wand. With this, you can enter text commands to configure, navigate, or run programs on any server or computer system. In this lesson, you'll discover how to use the command-line interface with Python and make that magic happen. Here's a VS Code window with a blank Python file on the top and a terminal at the bottom. In the Python file, write a simple print statement. I'll do print hello world. Go ahead and save this file as example.py. To run this file, use the following command in terminal: python3 space example.py. And it works. Next, you're going to create a new Python file called practice.py that refers to the previous file. To automate terminal commands with Python, you'll be using the subprocess library. Subprocess is a library that connects Python with the command-line interface. The subprocess library contains many functions, but the one you'll be working with in this lesson is the check call function. The perk of the check call function is it runs an executable in terminal and waits until the process has finished before continuing the script. Let's put this into action. First, I'll import the subprocess library. Next, I'll create a for loop that iterates over a range of 5 and gives the example.py file a try in each iteration. Inside the loop, I'll call subprocess.checkCall, passing in a list with Python 3 as the first element and example.py as the second element. This will tell the computer exactly what to do in the command line, as each element in the list represents an argument in the terminal command. Now save your changes. To test this out, run the following command in terminal: python3 space practice.py. The program works. It prints out hello world 5 times. Great! And with that, you now know the basics of executing terminal commands in Python. Ready to get your files in tip-top shape? Python can be so handy to sort and streamline your files and directories. In this lesson, you'll explore how to use Python to organize file directories. Now head to your exercise files and check out the Organize Me folder in your file system. Your goal is to create a program that generates new directories for each file type and organizes this directory. Next, open the Organize Me folder in VS Code and go to organize-starter-code.py. At the top, the first import statement imports the OS library, which contains functions for interacting with your operating system. Then the second import statement imports the path function from the pathlib library. Next, a dictionary named subdirectories is defined. It maps 4 basic categories: documents, audios, videos, and images to lists of specific file types. Then a function named organize directory is defined. This takes in a value that represents a file suffix it can encounter and returns a category based on the file suffix. This function requires a for loop to go through the items in the dictionary. If the function encounters a suffix that doesn't correspond to the 4 categories defined here, it returns a 5th category MISC to represent miscellaneous. To test this function out, call it on.pdf as an example and print out the result. Make sure to save your changes and then run the program through the terminal. As expected, you get documents as the output in terminal. The final function that's defined is Organize directory. This function requires a for loop to iterate through each file in the current working directory. If the directory that the file maps to already exists, it skips over the rest of the function body. Otherwise, a file path is created. From that, the file type is extracted. Next, the pick directory function that you defined previously is called to assign the correct directory to the current file. Then a directory path is created. If the directory path doesn't already exist, a new directory is created. Finally, the file path is updated to include the new directory path. Now you can call the Organize directory function. Time to test out the program. Before running the code, make sure your program is saved within the directory that needs organizing. In this case, the directory is Organize Me. In the terminal, first run the program. Then run the command ls to check whether the new subdirectories were created. There you go. You should find 5 new subdirectories: audios, documents, images, MISC, and videos. Go ahead and navigate to each of these subdirectories and check them out. All organized. And with that, you now have the power to organize directories with Python. Ever found yourself staring at a dense file of raw data, wondering how to extract the nuggets of information you need? In this lesson, you'll unlock the power of parsing in Python, a skill that will help you decipher raw data and extract precisely what you're looking for. I'll be showing you how to parse data with Python. You'll gain techniques for parsing different types of data sources, including TXT, CSV, JSON, and XML files in Python. From the exercise files folder, there are 8 files that will be referenced in this demonstration. To follow along, open up groceries.txt, groceries.csv, groceries.json, groceries.xml, parse data part1.py, parse data part2.py, parse data part3.py, and parse data part4.py. Let's start with parsing data from groceries.txt, which contains grocery data with commas separating one item from the next. The first step is defining the file path, which is groceries.txt in this case. Next is a with statement to open the file. Inside the with statement, file.read is used to read the data from the file, which is then saved in a variable named data. This will be a string that contains the grocery information. Afterwards, the data is printed out. To parse this data, the .split function is called. This splits the string of grocery data into a list, so each grocery item can be accessed individually. I've made the function split every time it encounters a comma followed by a white space. Then I've printed out the parsed data. As an example, if I wanted to access the grocery item at index 2, I could index the list and print it out. Go ahead and run the program to check out the result. As the output shows, the item at index 2 is carrots. Let's move on to parsing data from groceries.csv, which is a CSV file with 2 columns, grocery item and quantity. At the top, the CSV library has been imported. Next, the file path is defined, which is groceries.csv. Then there's a with statement to open the CSV file. Inside the with statement, the csv.reader function is called to read the data from the file. To separate the data from the headers, the next function is called. Finally, there's a for loop that iterates through each row of the remaining data. In the loop, the int function is called to convert the data type of the quantity value from string to integer. Then the row gets printed out. Go ahead and run this program. As you can see, each row of the CSV file has been printed out. Now it's time to parse data from groceries.json, which is a JSON file that maps grocery items to quantities. The first step is importing the JSON library, followed by defining the file path. Next is a with statement to open the JSON file. Inside the with statement, File.read is called to read the data. To parse the data with JSON schema, JSON.loads is called, and the result is saved in a variable named parsed data. To test out if this worked, I've printed out the quantity associated with the Apple's grocery item. Go ahead and run the program now. It worked. Apple's quantity :2 has been printed out. Lastly, parse groceries.xml, which is an XML file that represents a grocery list. The elements of this XML file represent grocery items. Each grocery item has a name and a price. The first line of code imports the element tree class from the xml.etree.elementTree module. This class represents the XML data as a tree structure, where each node is an XML element. Then the file path is defined. Next, the .parse function is called to parse the tree. Then tree.getRoot is called to get the root of the tree. Finally, there's a for loop that iterates through each grocery item from the root. In the loop, the name is extracted by calling item.find, passing in name as a string, followed by .text. The same thing is done for price. At the end, name and price are printed out. Go ahead and run the program. It worked. The names and prices of all the grocery items have been printed out. Now let's say you want to identify the grocery items that have prices higher than 6. To do this, create a variable named items_6 that starts off as an empty list. Inside the existing for loop, add an if statement that checks if the price is greater than 6. If so, append the name to the list. In the if condition, you'll need to call the float function to convert the price to a decimal before comparing it with 6. This is because in XML files, all values are represented as strings. So price is a string and needs to be converted to a number. At the end, add a print statement so you can display the final list. Save the changes and run the program. There you go. The name and price of each grocery item from the XML file has been printed out. And the last part of the output tells you that avocados, coffee, almonds, avocado oil, truffle oil, and saffron all have prices over 6. And with that, you now have the power to parse data with Python. Try implementing these parsing techniques on other TXT, CSV, JSON, and XML files of your own. Imagine yourself as a detective in a world dominated by digital data. You have to find specific information quickly and efficiently. But how do you sift through pages of text to find a clue? Enter the powerful tool of regular expressions. It can solve these mysteries by enabling you to search, match, and extract the data you need. In this lesson, I'll show you how to extract data with regular expressions in Python. You'll see how regular expressions enable efficient and flexible pattern matching for extracting and manipulating specific data from large and complex text sources. From the exercise files folder, open up Extract Data with regex startercode.py. The first line imports the read library, which contains a bunch of useful functions for working with regular expressions in Python. Regular expressions are a coding structure that allow you to extract data using patterns in text. Call the read.compile function and pass in a regular expression for identifying phone numbers in the format of 3 digits, followed by a hyphen, followed by another 3 digits, followed by a hyphen, and 4 more digits. Start with R, followed by a string that contains the pattern for identifying phone numbers. Use \d to indicate each digit. Create an example sentence to test out the regular expression. I've gone with the following sentence. The number is 123-456-7890. Then call .search on the regular expression and pass in the example sentence, saving the result in a variable. If the result was populated, which means a match was found, extract the phone number from the result and then the area code from the result. To extract the phone number, call result.group. Based on how the phone number is structured in the example string, let's assume that the area code is the first 3 characters. So to extract the area code, call result.group and then slice with square brackets, passing in index 0, index 3. Now save and run your code. Based on the output, the phone number and the area code were extracted correctly. And with that, you now have the power to extract data with regular expressions in Python. Practice using the re library in Python to create regular expressions for other data extraction tasks. Every day, millions of data transactions occur in the digital world, from simple online purchases to complex banking operations. A single error in these inputs can lead to disastrous consequences, such as financial loss or a breach of sensitive information. In this lesson, you'll discover how to automate input validation, a crucial shield protecting digital transactions from such errors. Start by opening up validate input startercode.py from the exercise files folder. The first line of code imports the PyInput+ library using the alias pyip for ease of use. Now let's dive into the first example. Call pyip.inputInt and pass in a prompt string that says, enter the number of shopping bags you will need for your items, followed by the parameter min set equal to 0. This means that when the program is run, the user will be prompted to enter the number of bags, and the program will validate the input. Specifically, it will check that the input is an integer and that it's greater than or equal to 0. Save the output in a variable named result, and then print it out. Time for a second example. Let's use another function for input validation. Call the pyip.inputMenu function, pass in a list of 3 colors as strings, set the lettered parameter equal to true, and the numbered parameter equal to false. Save the output in a variable named result, and then print it out after. Let's try out one more function for input validation as a third example. Call the pyip.inputEmail function, pass in a prompt string that says enter your email address, and save the result in a variable so it can be printed out after. When this program is run, the user will be prompted to enter their email address and the program will check if it's a valid email. Now save and run your code to check out how it works. Make sure to enter input when prompted. And it works. The program gathered all of the data that you provided. These are just a couple of examples of using functions from the PyInput+ library to validate data from user input. Feel free to check out the documentation on pypy.org/project/PyInput+ for more information, and practice using these functions on your own. Error handling is a crucial aspect of programming, and acquiring techniques for detecting and handling errors will help you take your Python skills to the next level. There are 3 major reasons why this is an important process. First, it enhances the robustness of the programs you develop. It ensures that unexpected situations like invalid inputs or unexpected data are handled gracefully rather than causing a program to crash. Second, it improves the experience of users who will use the programs you build. Instead of encountering cryptic error messages, users can receive informative feedback, making your application more user-friendly. Third, it makes debugging more efficient. When errors occur, the program can provide detailed information about the issue, helping you identify and fix the issues quickly. Also, it's helpful to keep in mind the 3 most common categories of errors you might encounter in Python programs. First are syntax errors. These occur when the code violates Python language rules. For example, a missing colon at the end of an if condition. Second are runtime errors, also known as exceptions. These occur when the program is executing and encounters an unexpected condition that prevents it from continuing. Examples include referring to a variable before defining it, name error, applying an operation or function to the wrong type of data, type error, accessing an index out of a sequence that's out of range, index error, accessing an attribute or method of an object that does not exist or is not defined for that object, attribute error, calling a function with the proper argument type but with the wrong value, value error, and trying to divide a number by zero, zero division error. Third are logical errors. These occur when the code runs without any syntax or runtime errors, but produces incorrect results due to flawed logic in the code. For example, a for loop that iterates over the wrong range. Error handling in Python is often done using try-except blocks, which allow you to catch and handle exceptions that might otherwise cause your program to crash or behave unpredictably. Another technique for error handling involves creating assert statements. An assert statement can often be used as a debugging tool. It's especially helpful in detecting logical errors based on specific conditions that you check for. Now that you've gotten a conceptual overview of the importance of error handling, the common types of errors to look out for, and techniques for error handling, you're ready to dive into implementation in Python. Welcome to the world of error handling, where each bug is a puzzle waiting to be solved. In this lesson, you'll dive into the crucial aspect of programming that deals with detecting and resolving errors that occur when a program is executed. Let's explore a couple of examples for how to automate error handling in Python. Open up Automate Error Handling Part1.py and Automate Error Handling Part2.py from the Exercise Files folder. Let's start with Automate Error Handling Part1.py. In this example, the goal is to get the user to input a number and perform a calculation with that number. However, there are two potential errors that you could get. The user might enter a non-number value, or they might enter 0 as the input. To handle these errors gracefully, you use a try-except block. The try block contains the code that might raise an exception. So if the user enters a value that isn't a number, a value error will occur. And if the user enters 0, the division operation will raise a zero division error. If an exception occurs within the try block, execution immediately jumps to the appropriate except block, based on the type of exception that occurred. So if a value error occurs, you print a message indicating that the input was invalid. And if a zero division error occurs, you print a message indicating that you cannot divide by 0. If no exception occurs, the except blocks are skipped and the code continues to execute normally. Now run the program to check out how it works. First, enter a number that's not 0. Then run the program a second time, and this time enter 0. Next, run the program a third time, and this time enter a value that's not a number. The try-except structure worked. Let's move to another example, where I'll use an assert statement to check for a logical error. Here I have Automate Error Handling Part2.py. In this example, years is defined as a list of numbers, and the goal is to sort the years in place. Let's consider what would happen if you accidentally used the wrong method. For example, if you called the reverse method, which reverses the order of the elements in a list. Afterwards, years is printed out, and there's an assert statement to check the logic of the code. Specifically, it checks if the first element is less than or equal to the last element in the updated list. This is a quick way to check if the list got sorted or not. Run the program. You'll notice an assertion error that is evoked due to the logical error from calling the reverse method instead of the sort method. This error message tells you what's wrong so you can easily fix the issue. Now you can fix the error by replacing reverse with sort. Save and run the program. And it works. No errors this time. By using try-except blocks and appropriately handling exceptions in your code, you can prevent unexpected errors, improve the reliability of your code, and provide a better experience for your users. Go ahead and implement try-except blocks and assert statements to automate error handling in your own Python code.